two propellers spinning opposite directions, and that instantly fixes a major flight problem. A single propeller creates torque that tries to rotate the aircraft, but a contra-rotating propeller cancels that effect by spinning the second prop the other way. That means better stability and smoother control. It also captures wasted airflow from the first propeller and converts it into extra thrust. Inside, a gearbox splits the engine power and drives both propellers in opposite directions, so you get more thrust, higher efficiency, and better performance without extra power. Simple idea. Serious engineering advantage. Watch this coaxial propeller system. One shaft drives two props in opposite directions using a compound gear setup. The rear prop straightens the airflow from the first, reducing drag and boosting thrust without needing more engine power. Why do workers pack machines full of grease? Are they overdoing it? It might seem like more grease means better lubrication, but that's not true. Grease is made of oil, thickener, and additives. When the machine runs, it releases oil that forms a protective film over metal parts. Too little grease? That film breaks and metal starts grinding on metal. But too much grease? It creates drag, heat, and can even damage seals. And those colors, red, blue, green, they're not for looks. They help identify different types of grease, but color alone doesn't tell the full story. What really matters is the grade, specs, and operating conditions. So next time, are you adding the right amount or just more? This automatic hacksaw cuts using back and forth motion instead of rotation. A motor drives a gear system that converts rotation into reciprocating movement. That motion pushes the blade through the metal continuously for controlled cutting. The smoother the ride, the more air is doing the work. That's the air suspension system. Instead of metal springs, it uses rubber airbags filled with compressed air. As the vehicle moves, air pressure adjusts to absorb bumps and vibrations. More pressure raises the vehicle, less pressure lowers it. This allows constant ride height and better comfort under different loads. So the system doesn't just support weight, it actively controls it. Watch this worm gear setup. The threaded shaft turns, sliding along the gear teeth and moving it step by step. It massively reduces speed while boosting torque, and most of the time, it won't reverse back on its own. See this moment under the fabric. The needle creates a loop, and the shuttle hook catches it instantly. It wraps that loop around the bobbin thread, then pulls it tight, forming a secure stitch that won't unravel easily. How does your car transmit power? While the wheels are turning and moving up and down? That's handled by the Resepa CV joint. This joint allows smooth power transfer even at changing angles. Inside, steel balls sit between an inner and outer race, guided by a cage. As the shaft rotates, the balls stay aligned, keeping the rotation speed constant. That's why it's called a constant velocity joint. Even when the wheel turns or the suspension moves, torque is delivered smoothly. No vibration, no speed fluctuation, just continuous motion. This is what keeps front-wheel drive cars running smoothly. Too much airflow hurts efficiency. That's why the variable inlet vane control damper is used. Its rotating vanes adjust airflow angle and volume before air enters the system. That improves control, stability, and efficiency instantly. This mechanism right here controls the tail rotor pitch, and it's the only thing stopping the helicopter from spinning like crazy. Every tiny movement changes thrust direction instantly, keeping the aircraft perfectly stable. Watch this freewheel mechanism. Those spring-loaded pawls lock into the teeth as you pedal, transferring power. The moment you stop, they click over the ratchet, disconnecting the drivetrain so the wheel keeps spinning freely. Focus on that line where the belt meets the cone CVT. That contact point keeps sliding along the surface, and that's what controls everything. No gears engaging, just position adjusting how fast or strong the output becomes. It looks perfectly flat. But that's exactly the problem. This is cylinder head skimming. When overheating warps the surface, it has to be machined back to precision. That blue dye? It reveals every imperfection. But take off too much and you increase compression, leading to even more heat. That's why every cut has to stay within strict factory limits. How do you drill through solid rock without snapping the tool instantly? That's where the Tricone rock roller drill bit comes in. Instead of one cutting edge, it uses 3 rotating cones with hardened teeth. As the drill spins, each cone rolls and crushes the rock beneath it. This spreads the load, reducing stress on a single point. The teeth are designed to chip and break rock efficiently under extreme pressure. At the same time, drilling fluid flows through the bit to cool it and carry debris away. So instead of slicing through rock, this system crushes and grinds it continuously. That's how drilling reaches extreme depths without failure. Did you know a chain drive can actually change rotation direction? It all comes down to how the chain is set up between the gears. In a normal setup, the driver and driven sprockets spin in the same direction because the chain just transfers motion directly. But if you cross the chain, kind of like a figure 8, it flips the rotation. So now, the second gear spins the opposite way. This simple tweak is super useful in machines where direction really matters. Same system, totally different result. See that small metal arm riding across the gear? That's the pawl flexing and snapping into every tooth. It allows smooth forward rotation, but the moment force pushes backward, it jams instantly and stops everything dead in place. See that angled rod connected to the wheel? That's the push rod pulling on a rocker arm, which then compresses the spring inside the frame. It shifts the suspension load inward, reducing unsprung weight and improving stability.